Friends, today we are going to discuss a very important equipment used in industry that is called storage tank. More or less, each and all type of industry needs this equipment that is tank in the process plant. So before going to discuss about the different type of tanks, we want to discuss why tanks are required. Because tanks are required as it is difficult to match the exactly production and the consumption. When suppose your consumption is more but production is less, then if you are having the storage tank, you can you can discharge the the less quantity of and keep the discharge as per your production if you are having a storage tank. Or suppose your production is more uh, and consumption is less, then also there is no problem. If you are having the storage tank, you can keep it store for your future requirement. Then in the process plant, we know in the refinery, petrochemical, food processing, that there is some reaction take place, and for that during that time also there is no production, but you keep dispatch keep the dispatch going on if you are having the storage tank. So what is the difference between the storage tank and pressure vessel? Pressure vessel storage tank maximum design pressure is less than 0.5 bar pressure. Pressure vessel maximum allowable pressure should be greater than 0.5 bar gauge, and API 620. That is the very important standard that is used for the tank. That is design pressure is maximum up to 1 bar gauge. There are different names of that for tanks. That is called storage tank. That the storage tank material, raw material, finished liquid products for storing. It is required storage tank. It is located away from the main product, main production. That is but situated inside the plant in the off-site area. Feed tank means boiler feed water tank. Then your diesel tank, that is required inside your production plant, because you need to feed the water or oil in the process. That's why it is called feed tank. Rundown tank means suppose your turbine is running, compressor is running, and your power failed, then lube oil system to no lube oil pump will be there to feed oil into the bearing housing. But if you are having the rundown tank during this failure condition of your AC and DC, there will no oil pump is running. At that time, if you are having the rundown tank, that will supply the oil to the bearing, and this will help to otherwise if your compressor is running, suppose, and there is no oil, or turbine is running, there is no oil, then your bearing will damage. But if you are having running tank, you can give provision, you can provide the oil supply. But this rundown tank having there are separate, there are so many features that we'll discuss later on. Similarly, blend tank is used for measure the quantity. Similarly, recovery tanks is there when suppose your spillage is there, liquid spillage is there, and you are storing it to a tank that is called recovery tank. Recovery tank, and there are so many slope tank, that is drain your collection of tank draining, then also it is called the slope tanks. So these are different type of tank used in the industry, and then these are the different type of standard that is used for manufacturing, or a different type of tanks. That is BS 2654 part 1, that is vertical mild steel welded storage tank. Butt welded cells. 803, that is also vertical cylindrical welded storage tank. Steel storage tank, mild steel storage tank, that is for design, fabrication, and erection. 650 is the welded storage tank for oil storage. 620, I have told you, the large welded pressure storage tank. That pressure is maximum up to 1 kg per centimeter square. one gauge bar. Similarly, 2000 is used for venting atmospheric low pressure storage tank, and API 653 is used for tank inspection and repair and alteration or and reconstruction. Then API 653 you can refer. Then that five type of storage tank that is called that is a fixed roof storage tank. If you see the drawing, a fixed roof storage tank, it's called the fixed roof. The roof is fixed, that's why it is called fixed roof storage tank. External floating storage tank. If you see there is external floating, there is no roof, but the roof is floating, external floating roof. This is a floating roof. Along with the liquid, it will float upwards and downwards. There is a ceiling at there at the between the inner shell and the roof. It will move along with the fluid. So it is called external floating roof tank. Then your internal floating roof tank. This is internal floating. You see this is closed, but still there is a floating roof is there. That's why it is called internal, because it is closed from the top. This is open external, but there is no roof. No roof. That's why there are difference. Then dome external floating roof. Dome external floating roof means you see these are dome. These are the domes. There is a lightweight aluminum sheets or bars are used. There is no vertical support is there. That's why it is called the dome external floating roof tanks. And horizontal tanks, there are horizontal tanks are also available. Pressure tanks, normally called the pressure vessel. Variable vapor pressure tanks. Then the pressure is varying inside the storage tank, is called variable vapor pressure tank. LNG tank, that is the natural liquid gas. For that also, the tank, special type of tank is being used, and then pressure tanks often are horizontal and oriented and spherically shaped. Normally, spherical shaped tanks are also available. And for horizontal, normally what we are doing, now 2:1 semi-elliptical heads or end caps are used at both ends to reduce the stress at the end. At the end. This is the A type of storage tank. This picture I have already shown you. That is called internal floating head storage tank. This is the external floating head. This is the fixed roof. This is the dome type external storage tank. There is no vertical column installed. Then spherical. The spherical vessels are very important, used in the industry, because it consumes less volumetric area, and plus its stresses are also less compared to the horizontal pressure vessels or tank. You see, if you see the drawing next page, this page, you see this is the horizontal tank or pressure vessel. Two type of stress are developed. One is called circumferential stress. That stress we are taking, that is sigma t, is PD by 2t, and longitudinal stress will subject the end cover are subject to longitudinal stress, that is PD by 4t. But if you are using hemispherical, you see everywhere it is circular, so its pressure will be PD by 40. So PD by 40 is less than PD by 2t. So, but that's why the hemispherical pressure vessel or tank are subject to less pressure compared to horizontal pressure vessel or tank. Then the surface area also I have told you the minimum. Suppose the surface area is of a sphere is, 2/3 pi r cube. Pi is missing by mistake. Pi r cube, and surface area of the sphere will be 4 pi r square. Similarly, suppose you are comparing it with the cylinder. So cylinder volume is equal to pi r square h. Cylinder surface area is twice pi r h, cylindrical portion. Plus both end there will be two end cover will be there, that is pi r square. If you suppose h is your what is the called length of the pressure vessel. So if you surface area, if you compare as it contain the same volume, that is 43 pi r cube is equal to here it is for pi r square surface area, pi r cube, and here it is this much. You compare this both, then you will get H equal to fourth r, fourth r, and then surface area of this cylindrical tank will be 83 pi r square plus twice pi r square, that is 4 into 2/3 pi r square, that is for greater than 4 pi r square. 4 pi square r square is the area, surface area of sphere. And here you see the cylindrical tank or pressure vessel. It is this 4 into 2/3 pi r square, that is greater than 4 pi r square. That is 4 pi r square. That's why the surface area of spheres are very compared to, are less than any other vessels. Now this is the vertical pressure tank or pressure vessel. The horizontal pressure vessel, we are choosing the end cover, that is called end cover is also subject to pressure. You see, but its pressure will be less if you are using mm, using the weakness is the but manufacturing of the spherical vessel is very difficult. Spherical pressure vessel is very difficult because to get this shape it is very difficult. That's why we are using the horizontal one. And LNG are the tanks used in the industry to storage the liquid natural gas. It can be installed in the ground. It can be installed in the railway or in a ship also. Also, it is particularly made of two tanks. Inner tanks are subject to the liquid natural gas. Its temperature will be around minus 165 degrees, 62 degrees centigrade. Inside and outside, there will be a vessel, there will be a tank. In between these two tank, inside the insulation will be there. Will maintain the temperature, and then you see that construction outside, inside that tank is there, that is subject to come in contact with the LNG. In between the outer shell is the inner shell. In between, insulation material is used. That's why the LNG can be kept in a liquid stage, that is minus 162 degrees centigrade. Similarly, ground floor is also subject to, you see the inner bottom. Then you see the secondary bottom also. Then vapor barriers are there. The purpose of vapor barriers is there, and after that vapor barrier, concrete support are there. So concrete, there may be some moisture, and that moisture can come through this. It can come on the insulation material. So if it is there, come inside the material of insulation, then insulation property will damage. That's why. Or if in the air also, if it come in contact, then also having some moisture, that bottom body vapor barrier will collect, will extract this vapor and keep this insulation in good condition. That is the LNG tank. So I think, friend, I have discussed the different type of tanks, LNG tanks, why purpose spherical tanks are huge, are compared to the horizontal or vertical vessels or tanks, because the surface area is less, as well as the stress developed on the spherical body vessels or tank is less, because poor 2D by less. It is only pressure is put 2D by PD by 40, that is less than the longitudinal stress, that is PD by 2T. 2T. So, but one difficulty is there. It is very difficult to manufacture this circular proportion, circular size. So, I think we have discussed everything here. If you go through this slide, your concept will be clear. So, if you don't clear, then you can talk to me, or you can mail me, or you can make a arrangement a video conference, so that when we can discuss and make your doubt clear. And if you are satisfied with this channel, then you could like it, subscribe it, so that in future also, in the tank itself, we are going to post so many posts that you can come to know. And if you are satisfied, you can refer this channel to your friends of the final year mechanical discipline, or your newly joined graduate engineer training, or experienced engineer also. They will be benefited with this post. Thank you very much.